plot the root locus. So we have solved a complex example yesterday. So let's go through some other examples. So let's say here, in this case, in this example, we have this transfer function, this g of s, is k by s into s square plus 4s plus 8. So you can see here we have only 3 poles, 1 pole at origin and 2 complex conjugate pole. Okay, so the first step is we have to identify the poles and zeros. So we don't have any zero, we have only 3 poles. So for this equation, s square plus 4s plus 8, we will get these 2 complex conjugate pole, that is plus minus j2, and we have another pole at 0, right, for this s pole at the origin. So s1 is 0, s2 is minus 2 plus j2, and s3 is minus 2 minus j2. The next step is we have to determine the centroid of the asymptote. Okay. The centroid is, the formula for centroid is sum of poles minus sum of zeros divided by number of pole minus number of zero. So we have 3 poles and we don't have any zero. So the number of poles is 3 and we don't have any zero. So we will get minus 1.33 as our this centroid of asymptote. The next step is to determine the angle of the asymptotes. So you know this formula, this phi, or you can write psi also. So 2k plus 1 divided by p minus z into 1, 8. So for k equal to 0, we will get the phi 1 to 60 and phi 2 equal to 180 and phi 3 is 300. Similarly, next the breakaway point, we have to determine the breakaway point, right? At which point they will break away. So in this case, you have to determine, but from the pole 0 location, we can say that there will not be any breakaway point. So for just curiosity, just let's check that whether there will be any breakaway point or not. So to determine the breakaway point, we have to first formulate this characteristics equation. So it is 1 plus, this is our g of s, right, k by s into s square plus 4s plus 8, and our h of s is 1. We have a unity feedback system. So this is equal to 0. So k is minus s cube plus 4s square plus 8s. This is our dk by ds. After dk by ds, we will get this minus 3s square plus 8s plus 8. So equating this to 0, we will get the value of our this breakaway point, right? So 3s square plus 8s plus 8 equal to 0, because this is dk by ds. So to calculate the breakaway point, we have to do this dk by ds. So from this equation, you can use your calculator, or by using this formula minus b plus this minus b plus minus this b square minus 4ac. You can also try. So s, we are getting this point from this dk by ds. We are getting the value of s is equal to this one, this minus 1.33 plus minus j 0.943. We are getting a complex conjugate breakaway point, 2 breakaway point we are getting. Okay. So we have to check whether either this will be a breakaway point or not. So breakaway point means the breakaway point should lie in the root locus path. Okay. So how can we check that? So we can check this by the angle condition. By this angle condition, by putting the value of s equal to this one, we can check that this angle condition is not satisfied. So there will not be any breakaway point on the real axis. The next step is we have to determine the point of intersection with the imaginary axis. So for that, we have to use the characteristics equation and then the Routh array. So we know the Routh array, right? So we are getting our characteristics equation s cube plus 4s square plus 8s plus k equal to 0. So we have to write in the decreasing order of the power of s, and then this is the coefficient of s cube is 1, and then 8, and then 4, and then k. Okay, 4 and k. So by cross multiplying, we can see that we are getting 4 into 8, 32, minus 1 into k divided by 4. So it will be 0. And similarly, if there is no term below this k, so this will be k. So we have to make all the elements of a row 0. So we cannot make this k 0, right? So we have to make this element 0. So you can see the 32 minus k divided by 4 should be equal to 0, so that we will get a sustained oscillation. Or we can say during sustained oscillation, our roots lie on the j omega axis. So 32 minus k equal to 0, so k equal to 32. So for the value of k equal to 32, the gain value of 32, we are getting a marginally stable system, or we can say we are achieving sustained oscillation in the output. So then how can we solve this Raoult array? So we have to use the auxiliary equation. So this row, all the element of this row becomes 0. So we have to use this equation, the auxiliary equation. So it will be the power is a square, right? So 4a square plus k equal to 0. So k, the value of k is 32. So it is 4a square plus 32 equal to 0. So from this equation, we can find the value of s, which is plus minus j 2.83. Similarly, as we have complex pole, right? The complex conjugate pair of pole, we have to determine the angle of departure. If there are only real poles, then we don't have to calculate or determine the angle of departure. If we have complex conjugate pair of pole, at that time we have to determine the angle of departure. The angle of departure formula is 180 degree minus summation of angle contribution by the poles, all other poles. Okay, so we'll see this example. Okay, so the first thing is we have to plot the pole 0, right? The pole 0 map. So we have a pole at the origin first, and then another 2 pole is minus 2 plus j2 and minus 2 minus j2. So if it is 2, it is minus 2, 2 is 0, this is minus 1. So the pole will lie at this point. We have to use the graph paper, okay? I am just drawing in the simple paper, but you have to use the graph paper. So we are getting 3 poles in the, this is j2 and this is minus j2. Okay, this is our 3 poles. One pole at the origin and other 2 are the complex conjugate pair of poles. So next step is we have to draw the centroid, right? We have to find the centroid from which we will draw the asymptotes. The centroid is minus 1.33. So we have to mark a point. So 1.33 will be at this point, right? The minus 1.33, our centroid. At this point, we will get our centroid. That is the minus 1.33. This is our centroid. So now from this centroid, we will draw our asymptotes. So what are the angle of the asymptotes? 60, 180 and 300 degree. So 60 will be this one, and 180 is this one, and 300 is this one. Our asymptotes are 60, 180 and 300. So we have 3 asymptotes. So next we have to see from which our root locus will start. Okay. So we know the root locus start from the open loop poles, and it will terminate either on infinity or on a 0. So we don't have any 0. So all the root locus branch will terminate on infinity. So we have to see at which point. For this real axis, we can see, right, any point. If we choose any point in this negative axis, that path will be on our root locus. Clear? Because any path in this real axis, towards its right, there is only one pole. So this path, this all the path, it will lie on the root locus, and this root locus will follow this 180-degree asymptote. So this will be our first root locus branch. Okay, the direction will be in this side, with the direction of the first root locus branch, and this root locus will follow the 180-degree asymptote, right? This 180-degree asymptote. So then next, from these two complex pole also, there will be a root locus branch, right? So how can we check that what will be the, and at which angle the root locus will start? The root locus may originate like this, it may originate like this, or this, or this, right? So for this, we have to find the angle of departure, so that we can say the root locus will start or depart from that angle. So how can we measure the angle of departure? So the angle of departure, phi d, is equal to 180 minus the summation of the angle contribution by the pole. There is no zero, so if there is zero, so it will be plus the summation of angle contribution by zeros. Okay. So we don't have any zero here, so we'll limit to this pole only. So we have, so for this pole, we have to calculate the angle of departure, right, for this pole. So we have other two poles left, this origin and this other one, the mirror image one. So from all other poles, we have to draw the lines. Okay. So from all other poles, we have to draw the lines. Clear? So this will be obviously 90-degree, right? This will be, we don't have to measure it. So one is 90-degree. So we can write it is 180 minus 90, then plus this angle. We have to calculate this angle, right? So how can you calculate? So by using this right angle triangle, right? This right angle triangle. So we know in right angle triangle, this angle, right? This angle can be calculated by, so let's say this is alpha. So alpha is equal to tan inverse of P by B, right? Tan inverse of P by B. So this is our P, and this is our B, and this is H, right? You know. So for this right angle triangle, so that means we have to, for this right angle triangle, right, this right angle triangle, we have to find this angle. You can find this angle. So here P is the perpendicular one. So what is the value of P here? Anyone? The length of P is how to show angle of departure. I am not going to do that. So first let's calculate that what is the angle of departure. Okay. So what is the length of P in this right angle triangle? Anyone?
So 2.
2, right? The length of P is 2, because in this case we have plotted it against this J2. The length of P is 2 here. Similarly, what is the length of this B?
So 2.
2, right? This is 2, from 0 to minus 2. So this is tan inverse 2 by 2. So what will be the value? What is the value of tan inverse 1?
45 degree.
45, right? So what is the value we are getting? 180 minus 90 plus 45. Oh, sorry. I made a mistake. This is 45, right? This angle is 45. But we have to measure this angle. So if it is 45, then it is 135. Right? This angle is 135. It is 90 degree. Clear? From this side, we have to see the angle. But this angle is 45, but this is 135. The angle contribution by the pole at the origin is 135 and the angle contribution from this lower complex pole is 90 degree. So we will get this one should be 135. So we are getting minus 45 degree. Clear? Sorry, my bad. I assume this angle. So clear? How to calculate this phi d? This angle of departure? Anyone?
Yes, sir.
Clear? Okay. So we can calculate by using this tan inverse P by D. Okay. So suppose at 1, okay, at minus 1 there is a pole. That means we have to calculate another angle, right? So this will be this one. We have to assume this right angle triangle. So at that time P is 2 and B is 1, right? From minus 1 to minus 2 is 1. So we have to add another angle. So but in this case we have only 2 other poles except this one. So now we have our angle of departure is minus 45 degree for this upper complex pole. Similarly, for this lower complex pole, it will be 45 degree. Okay, we don't have to calculate. If it is minus 45, then it will be 45. If it is 45, then it will be minus 45. So, okay. So then we have to draw minus 45 degree from this pole. So let's say this is our line, okay, up to this J2. So with reference to this line, we have to draw this minus 45 degree. So let's say this is our okay. So let's draw this minus 45 degree. So this will be minus 45 at this angle. This will be minus 45 degree. So this is the angle of departure. That means the root locus will depart this pole at an angle of minus 45. The root locus will start like this one. From this pole, the root locus will go like this one and it will follow this asymptote, right? It will follow this asymptote. So similarly, the angle here for this lower complex pole, it will be 45 degree. So this is the 45 degree. So the root locus will start like this and it will follow this asymptote, right? Here, so now we can see this root locus will intersect this j omega axis. So we have already calculated at what point it will intersect the j omega axis. So this is calculated by using the Routh array. So we have calculated at s equal to plus minus j2.83, it is intersecting the imaginary axis. So at j2.8, this is positive one, so j2.8, sorry. j2.8 and it will be minus j2.8, right? So at this
Sir?
point, yes.
सर asymptote जेहेतु infinity को extend होची तो root locus टा भी infinity को extend होगा.
हाँ, रूट लोकस टा भी इंफिनिटी को एक्सटेंड हो. हमें कहीं की इंफिनिटी क्लियर एग्जांपल क्लियर यदि कहार के डाउट अछि पचार आउथर में कहि.
सर 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 जो ऊपर जो पोलटा अछि जो पॉजिटिव कॉन्जुगेटटा सेटा माइनस j2 पाखरे जो asymptote अछि ताकू कहीं एमती डायरेक्ट फॉलो करला नहीं रोटेट करी कहीं की वाला
ना ना से त पाकटा को ही फॉलो करियो हला तळो को आसीयो नि एपटे.
ओके सर.
से तार जो एसिम्टोट से ऊपर को एपट अछि ना से ऊपर को ही जीवो. त नियरेस्ट टाइप से फॉलो करियो ना एपट थोड़ी ना से आसी फॉलो करियो तो.
ओके सर.
जीवन मान सब पूरा बुझी गेले होते.
सर सर
सर प्लीज आउथरे
Sir.
कोट आउथरे कहि को
से लोकस पट्टा केंद्र ड्रॉ लाउ थरे टिके
फास्ट लोकस पार्टटा. ओके ठीक है ताले मु आ गुटे एग्जांपल करू जी हला एग्जांपल छाडी की ठीक अछि.
यस सर
এটা আমি করলে কালি তো এটা হলো তার রুট লোকসটা ওকে এক্সাক্ট রুট লোকস যেটা আমি ড্র করলে বর্তমান এটি -135 লিখছি ওকে ছাড়ো ওকে যদি গোটে 0 আছে সেটা এন্টার করিয়া হেলে we have a 0 and 3 poles. So first we have to identify the poles and 0. So we have 2 poles at origin, right? S square means there are 2 poles at the origin. So 0, 0 and another is -3.6. Clear? And we have 1, 0 at S equal to -1. Clear? I think this is easy. You can identify the pole and 0. So it is written here that segment between this S equal to -1 and -3.6 is the part of the root locus. So we can see after this plotting. Okay, you don't have to even write this one. So the next step is to determine the centroid of the asymptote. So this sigma A equal to the sum of poles minus sum of 0 divided by P minus J. So we have 2 poles at 0 and another pole at this -3.6, and then we have a 0, right, at -1. So minus plus 1, then 3 minus 1. So we are getting our centroid to be -1.3. So then we have to determine the angle of asymptote 2k plus 1 by P minus Z into 180. We will get 90 and 270. The next thing we have to determine the breakaway point. So anyone have any doubt regarding the determination of breakaway point? Because I will focus on how to draw. Okay, I will not go over this calculation. So if anyone have any doubt regarding this calculation, you can ask. Right, we have to do dk by ds equal to 0, and we can see this. What will be the value of s? So we are getting two value of s at s equal to 0 and s equal to -1.65 plus minus j 0.936. Okay, we are getting these two breakaway points. So we have to check that which point will be the breakaway point. So it is written that point s equal to 0 is the actual breakaway point, and this is a complex quantity, so this will not be breakaway point. That does not mean that complex quantity cannot be breakaway point. Okay, it can be. We have to check that. Complex quantity also can be breakaway point. So next, the intersection at the j omega axis by using the Rao-Thorich. I think all of you are thorough about this, how you can do this. Okay. So for sustained oscillation, in this case, the k equal to 0. So we are getting s equal to 0. So that means the root locus branch will do not cross the j omega axis. Will do not cross the j omega axis. Here all the points.
Yes,
In
sir.
this
Yes, sir.
एथिरे
Yes,
हमर
sir.
कॉम्प्लेक्स पोल है ठीक अछि सो एटा देखिया फर्स्ट हम so first one is to we have to draw the pole 0 map. So one pole at or two pole at origin, right? Two pole at origin and another pole is at -3.6 and 1 0 at -1. Okay, yeah. So now tell me, will this region will lie on the root locus? This region
Yes.
from 0 to -1.
Yes, sir.
How? Yes.
No, sir.
दीटा पोल अछि परा या राइट साइड रे
तो रहिबनी ना
रहि हसे तो रहिबनी दीटा पोल अछि राइट साइड रे तो रहिबनी हला जदि हम एई पोल को कंसीडर करिबा देन 0 मझी रे रूट लोकस हम लाई करिबो हला दीटा पोल गुटे पाखे एडजेसेंट पोल ना तो सेथिरे हमरा रूट लोकस रहिबो हला 0 0 मझी रे माने कर दीटा पोल अछि ना 0 0 रे तो यांको मझी रे रूट लोकस रहिबो हला या मझी रे
ଟିକେ ଆଉଥରେ ବୁଝେଇ ବୁଝିହେଲାନି
सर जदि सेटा मझिरे रे हम ताको शो करिया केमती माने डायग्राम रे एमती
करूची म कहूची हला
ओके
तापर ए रीजन रे रहिबो कि नाही -3.6 रु -1
रहिबो सर
এটা রহিবো কাহিনা না রাইট সাইড রে তিনটা পোল 0 আছে হলা so we know that root locus will start from open loop pole and it will terminate on open loop 0. Okay, and what are the centroid? Centroid is minus 1.3. So at this point we have our centroid, and the angle are 90 and angles
70.
Oh, ସେଠି ଥିଲା ତ 90 and 270. Then we know our root locus will start from which point? From open loop poles, and it will terminate on open loop 0. So as we know, this path will lie on the root locus, right? This path will lie on the root locus. So one root locus will start from this open loop pole, and it will terminate on this open loop 0. The direction will be this one, right? Open loop pole will start hoiki open loop 0 re terminate hobo. So the direction will be this one, because the root locus branch is moving from this minus 3.6 to this minus 1. And we have determined the breakaway point. So we have determined two breakaway points, right? This S equal to 0 and another one the complex one. So as in this diagram, we don't have any complex conjugate pole, so the complex breakaway point will not be the breakaway point. Okay, but we have another breakaway point at 0. Clear? Breakaway point गोटे 0 रे अछि आ गोटे complex conjugate रे अछि. तो जेहेतु हमर एई ट्रांसफर फंक्शन रे complex conjugate pair of pole नाही, then you can easily neglect that the a point हमर breakaway point होबनी complex conjugate pole टा. So आ गोटे point रहिला 0 at 0 रे. So माने कर suppose this is 0 and 0. Okay, just I am magnifying this. This is 0 and 0. So that means the root locus will start from these two pole also. At A00 pole will be theta root locus branch start hobo, and then they will meet at some point and they will break away. Right? They will meet at some point and they will break away. So the breakaway point is also 0. We have calculated the breakaway point is also 0. So we can draw the root locus like this one. It will be like this one, right? Because these branches will follow this asymptote. Or you can draw the closure like this one also. Because these two root locus branches will follow these two asymptotes. Okay. And we have determined there will be no cross section. The root locus branches do not cross the j omega axis. So we are confirmed that the root locus will not move in this direction. Okay. Hear this one? I think confuse galo.
सर जदि एडी डेटा जीरो थांता
कोठी एटी मन कर आ गोटे जीरो थांता ताले हमरा पूरा चेंज हे जीवो ना, जे रूट लॉकस जो पाथ चेंज हे जीवो, एंगल ऑफ एसिम्पटोट चेंज हे जीवो. ए दीटा पोल दीटा जीरो एग्जांपल अछि हम देखिबी तुम गुरु हो सेमति अछि ओटे थिला दीटा पोल ता जीरो थिला ना कोन थिला. एटेंती गोल भी हे परिबो ले रूट लॉकस. एग्जांपल टा मु स्कैन करनी बोते हला तमे ट्राई कर हला दीटा पोल आ दीटा जीरो नै कि तमे ट्राई करो हबो हला ई स्टेप पूरा फॉलो करो हे जीवो.
सर सर ब्रेकअवे पॉइंट गोटे कॉम्प्लेक्स नंबर पूर्व क्वेश्चन टा लिखाइला कि कॉम्प्लेक्स नंबर हे परिबोनी.
कॉम्प्लेक्स नंबर हे परिबो जदि तमरो कॉम्प्लेक्स कंजुगेट पोल अछि. एठी हमरो कॉम्प्लेक्स कंजुगेट पोल नाही, सो तमे ताको नेग्लेक्ट करि परिबो हला जे सेटा होबन. मने कर एठी गोटे कॉम्प्लेक्स कंजुगेट पोल थांता हमर एठी हला ता माने एठू भी स्टार्ट थांता रूट लोकसटा. ए पाथ यदि आसुथिबो देन दे कैन ब्रेक हियर, राइट? यदि हमर कॉम्प्लेक्स कंजुगेट पोल ही नाही ताहेले हमर कॉम्प्लेक्स टा ब्रेकअवे पॉइंट होबन.
यस सर.
एग्जांपल अछि रो कॉम्प्लेक्स कंजुगेट जोटा हमर ब्रेक अवे पॉइंट अछि स्कैन करनी होती ना कौन एग्जांपल टा भल एग्जांपल टा थिला स्कैन करनी होती एई डाटा एग्जांपल टा देखो एई जगह रे हमरा ब्रेक अवे पॉइंट अछि सो सॉल्व करिवा एग्जांपल टा ये s plus 4 s square plus 4s plus 20 draw the root locus for a system whose open loop transfer function is given by this one, okay, k by s into s plus 4 into s square plus 4s plus 20. So first we have to plot the pole and 0. अरे मोटा आधा स्कैन कर छाड़ दीजिए बोले ओके सो पर हम वही है सो आई मु भाबुची तमे कैलकुलेशन करि दबो तो जस्ट मु खाली पॉइंट गुडा लिखि दोछि हला तापर हम ड्रा करि देखिया केमती ड्रा हबो transfer function we can see that we have four poles, right? One is s equal to 0 and s equal to minus 4 and 2 complex 4. So s equal to, so let me just plot, okay, directly. So we have four poles. One is at this origin, another is at this minus 4, and from this s square plus 4s plus 20 we will get two complex conjugate pair of pole, that is this minus 2 plus minus j4. So this is, let's say this is minus 2 j4, this is minus j4. So we have complex conjugate pair of pole here. Okay. Minus 2 plus j4 minus 2 minus j4. So similarly, the centroid you can calculate the summation of pole minus summation of 0 divided by number of pole minus number of 0. So we are getting the centroid to be minus 2. Similarly, the angle of asymptote will get 45, then 135, then 225, and then 315. This will be the angle of asymptotes. So centroid is minus 2, so we have to draw these four asymptotes from this centroid minus 2. So this is a minus 2, so we will get our asymptotes will be this one. This will be the asymptotes. Okay, this is 45, this is 135, this is 225, and this is 315. So we have four asymptotes. So similarly, we have to determine the breakaway point by dk by ds. dk by ds is equal to 0. So we are getting the breakaway points, three breakaway points. Okay. From this solution, one is minus 2 and another two are minus 2 plus minus j 2.45. Okay, so we are getting these three breakaway point. So we have to check that whether which point will be the breakaway point. And we know the breakaway point will exist between two adjacent poles. So here we can say these two are also adjacent pole. These two are adjacent pole. So first let's see the real axis. So we can see between these two poles, right, this 0 to -4, we can see that this path will lie on the root locus, right? This path will lie on the root locus because towards its right there is only one pole. So we have -2. So the -2 will be a breakaway point. Clear? And similarly, we have to check here this -2 plus minus j 2.45. So by using the angle condition, you can check whether this it will be the breakaway point or not. But in this case, it will be a breakaway point. So to make sure, we have to use the angle condition. Okay. So let's then we have to determine the angle of departure because we have this complex pole. So we have to determine the angle of departure phi d. So phi d is equal to 180 minus the summation of angle contribution by pole. There is no 0, so poles. So that means for this upper complex pole, we have to draw lines from all other poles. So this line, there will be this line and this line. Okay. So this is 90 degree, so we don't have to measure it. Okay. So we have to measure this angle and this angle. So similarly, the right triangle, this one for this first one, right, for this first one, what is P and what is D? Anyone? What is P and what is B? The value of P and B?
P4, B2.
Okay, P is 4, right? The perpendicular branch length is 4 and B is 2. So you can do this, you can calculate this angle by tan inverse of 4 by 2 and then minus 180 degrees. So we will get this angle, right? Let's say this is phi P1. Similarly, this is phi P2. This is phi P3 is 90 degrees.
Sir,
Yes.
sir, 5p1 और 5p2 टा सॉर्ट by anti-clockwise direction में measure करियर अच्छे.
এই angle measure करिवा हमें. এই पटु हमें angle contribution नबा है ला. এই direction to anti-clockwise.
Okay, sir.
So this angle contribution is phi P1. So it will be 180 minus tan inverse of 4 by 2. Similarly, a angle कितने होगा? Anyone? What will be the value of this angle? It will be tan inverse of 4 by 2 because this angle. So we don't have to subtract it with 180 degree because we are measuring this angle. So from this triangle, this angle will be tan inverse 4 by 2. So now we have calculated the angle contribution. Okay. So 180 minus the summation of angle contribution. So we are getting the value to be minus 90 degree for this upper pole. Similarly, for this lower complex pole, it will be 90 degree. Okay, you can calculate. It will be 90 degree. Okay, clear? So we have to draw the line. Similarly, from this will be 90 degree. So that means the root locus starting from this complex pole will go in this direction. Right? It will go in this direction. So, so let's start with the real pole. Okay. The real poles from this pole, there will be a root locus branch. From this pole, there will be a root locus branch, and then from 0 also there will be a root locus branch. Clear? And we know the breakaway point is -2. So at -2 they will meet and break. Right? They will meet and break in this direction. So as you know, we have checked that this -2 plus minus j 2.45 is also a breakaway point. That means the root locus starting from these complex poles, they will meet at this point of minus 2 plus minus j 2.45, and now they will break, and one will go in this direction and other will go in this direction. Similarly, one will go in this direction and here the other one will go in this direction. Clear? फिर ना confuse ହେଇଗଲ?
सर लास्ट पार्ट टिके आउथरे
अच्छा
जो ड्रॉ केमती कराला सेही पार्ट खाली
तो फास्ट हम रियल पोल स्टार्ट करबा ओके तो मैं जाने जो रूट लोको स्टार्ट हबो हमरो ओपन लूप पोल रु और टर्मिनेट हबो ओपन लूप 0 रे तो 0 नहीं एठी हमरो सो रूट लोको से ब्रांच जीवो इंफिनिटी को क्लियर तो ताहले ए जो -4 और 0 रु जो रूट लोको स्टार्ट हला से कोन गोटे जगह रे मीट करिवे मीटिंग पॉइंट है ब्रेक अवे पॉइंट जोटा कि आम बाहर करें -2 राइट सो -2 से मीट कले एंड दे विल ब्रेक ओके दे विल ब्रेक तो सही टाइम रे हमरो एक कॉम्प्लेक्स पोल रू भी बाहर होची रूट लोकसटा से काहे कि सीधा आछि कॉम्प्लेक्स पोल रूट लोकस एनीवन
सर डिपार्चर एंगल 90 डिग्री सर
Yes,
270 डिग्री
departure angle is 90 degree okay, -90 degree here in this case and in this case +90 degree
यस सर
ହେଲା ତ ସିଧା ଯିବ ଏଇ କେସ୍ ରେ ତ ଏଇ କେସ୍ ରେ ଗଲା ବେଳକୁ ଯେହେତୁ ଆମେ ଏଟା ବାହାର କରିଛେ ଯେ ଏଇ ପଏଣ୍ଟଟା ବି ଆମର ବ୍ରେକ୍ ଅୱେ ପଏଣ୍ଟ ତାହେଲେ ଏଇ ଯୋଉ ଦିଟା ରୁଟ୍ ଲୋକସ୍ ବ୍ରାଞ୍ଚ ଆସିବେ ସେମାନେ ସେଇ ପଏଣ୍ଟରେ ମିଶିବେ ଆଉ ମିଶିଲା ପରେ କ'ଣ ବ୍ରେକ୍ କରିବେ ଗୋଟେ ଏପଟେ ଯିବ ଏଇ ଏସିମ୍ପଟୋଟକୁ ଫଲୋ କରିବ ଆଉ ଗୋଟେ ଏଇ ଏସିମ୍ପଟୋଟକୁ ଫଲୋ କରିବ ସିମିଲାରଲି ଏଇ କେସ୍ରେ ବି ଯୋଉଠି ମାନେ ମିଟ୍ କରିବେ गोटे ए एसिम्पटोट को फॉलो करिवो आ गोटे ए एसिम्पटोट को फॉलो करिवो इंफिनिटी क्लियर
यस सर
जहां डाउट जे पचार हला किछ असुविधा नहीं तो तापर देखिबा ए जो रूट लोकटा जाउची हमरो से जीएम एक्सिस को कट करिवो राइट जीएम एक्सिस को कट करिवो सेटा केमती बाहर करिया हमें राउथ ओरिज रु सेटा केते बाहर सही पॉइंट राउथ जाउची s इक्वल टू प्लस माइनस j 3.16 ताहले मोटी ऊपर को नहीं गली एटा ए पाखा पाखी आसीबो हला ये रूट लोकस ब्रांचटा तो ग्राफ पेपर रे करबो तो ठीक आसीबो हला मोटी कला बेलू को
सर कवर गुड़ा तो फ्री हैंड ड्रॉ करिया ना ग्राफ पेपर रे
हां खाली तुमको देखिया जे को पॉइंट से माने मीट करूचंती क्रॉस करूचंती सेतना ग्राफ पेपर रे से पॉइंट गुडा दबो हला एडा हे गले किछ असुविधा नहीं माने कर तुम एमती पळेला हला एमती पळेला किंतु तुमे एठी 3.6 थिबा दरकार एठी 3.16 तो एटा भी 3.16 ए पॉइंट -3.16 तो ए पॉइंट रे हमरो गोटे रूट लोकस ब्रांच इंटरसेक्ट करिवो जीओमेगा एक्सिस को आ गोटे ब्रांच जीवो इंफिनिटी एटा ए जो ब्रांचटा एटा कट भी करि पारे हला एसिम्पटोट को किछि प्रॉब्लम नाही किंतु ताको फॉलो करिकि इंफिनिटी को जीवो तो हमको एटा दरकार नाही एपटे कोन रहिला दरकार नाही हला लेफ्ट हैंड साइड जा हो किछि असुविधा नाही हमको देखिए राइट हैंड साइड पटे कोन जिंस होउची
सर राइट हैंड साइड रे इंटरसेक्शन पर आ एक्सटेंड करिवर नै रूट लोकिटा
ना किछि करिया दरकार नाही हला
ओके सर
तो एते बेले रूट लोक से बनौचे ग्राफ पेपर रे मु एपटे लंबा लाइन कोन पॉइंट आनी जे एपटे कोन पॉइंट आनी जे काहे ना एपटे हमको दरकार नाही हमको एपटे जिंस दरकार हला जस्ट क्रॉस करिकि छाड़ दो खाली इमेजिन राइट हैंड साइड को आसीलो नले ग्राफ पेपर तुम यदि मजा मजी करिवो रूट लोकसटा ताहले तमरो एपटे जगह पाइबोनी लेफ्ट हैंड साइड को अच्छी ग्राफ पेपर पेपर किसी काम करूँ तो तुम ग्राफ पेपर ट्राए कर है नॉर्मल ग्राफ पेपर ट्राए कर और मत कहब जब किसी इश्यू अच्छी किसी प्रोब्लेम फेस करुच है मत कहब तो तुम पाखे को बही कि ना कि
सर किणी गोटे
କୋଉ ବହିଟା କୋଉ ଅଥର
ସାର୍ ମୋ ପାଖରେ ଗୋଟେ ମିନିଟ୍
କଣ୍ଟସ୍ ବିଟେକରେ ଆଉ ବହି ନା ଦେଖନ୍ତି ନା ଅଥର ନା କୁହନ୍ତି।
ସାର୍ ଆଇଜେ ନାଗରାଜ ଏମ୍ ଗୋପାଲ ଆଇଜେ ନାଗରାଜ।
ହଁ ସେଟା ଭଲ ବହିଟା ହେଲା, ସେଥିରେ ଭଲ ଦେଇଛି। ଏ ଯୋଉ ସେଠି ଦେଇଛି ସେ ବହିରେ ତମର ଯେ ରୁଟ୍ ଲୋକସଟା କାହିଁକି ଓପନ ଲୁପ୍ ପୋଲରେ ଷ୍ଟାର୍ଟ ହେଇକି ଇନଫିନିଟି କି ତମର ଜିରୋରେ ଟର୍ମିନେଟ୍ ହବ ହେଲା। ଆଉ ତାପରେ ସେଣ୍ଟ୍ରାଲର ଫର୍ମୁଲାଟା ସେମିତି କ'ଣ ପାଇଁ, ଏଙ୍ଗଲ ଅଫ ଇନସିଡେଣ୍ଟଟା କ'ଣ ପାଇଁ ସେମିତି ବାହାର କରାହୁଏ, ସେ ସବୁ ଦେଇଛି ହେଲା। ତ ସେ ତମ ଆସାଇନମେଣ୍ଟ ଦେବି ମୁଁ, ସେଇଟା ତୁମେ ପଢିବ ଟିକେ ସେଇଟା।
ସାର୍ ନର୍ମାଲ ନାଇସ୍ ଅଛି,
ହୁଁ
ନର୍ମାଲ ନାଇସ୍।
ହରମାନେସରେ ତ ଆହୁରି ବଢିଆ ବହିଟା, କିନ୍ତୁ ବୁଝିପାରିଲେ ହେଲା ଷ୍ଟାର୍ଟିଂରେ ଟିକେ ହେଲା। ୱିଲିର ପ୍ରାୟ ବହିଗୁଡ଼ା ଭଲ ଥାଏ ହେଲା, ୱିଲି ଯୋଉ ପବ୍ଲିକେସନର, କିନ୍ତୁ ତମେ ତାକୁ ଟିକେ ଆରାମରେ ଧୀରେ ଧୀରେ ପଢିବାକୁ ପଡିବ। ତ କାହାର ଆଉ କିଛି ଡାଉଟ୍ ଅଛି ରୁଟ୍ ଲୋକସରେ? ଏଇ ରୁଟ୍ ଲୋକସ ଟ୍ରାଏ କର ହେଲା, ତମେ ନିଜ ଆଡୁ ଟ୍ରାଏ କର। K ବାय S into S plus 6 into S square plus 4S plus 3। ତ କାଲି ମୁଁ ସମସ୍ତେ ସ୍କାନ୍ କରିକି ରଖିଥିବ ହେଲା, ସ୍କ୍ରିନ୍ ସେୟାର କରି ଦେଖେଇବ କିଏ କ'ଣ କେମିତି ଡ୍ର କରିଛି। ଏଇଟା ଗ୍ରାଫ୍ ପେପରରେ କରିବ, ଗ୍ରାଫ୍ ପେପର ଅଛି ନା ନାଇଁ? ହଁ ମିଳିଯିବ, ଦୋକାନ ସବୁ ଖୋଲା ଅଛି। এটা ବହୁତ ବଢ଼ିଆ ଅଛି ରୁଟ୍ ଲୋକସଟା। K by S into S plus 6 into S square plus 4S plus 30। ତେଣୁ ମୁଁ ସେୟାର କରିଦେବି এই ପିଡିଏଫଟା, ସଲ୍ୟୁସନ୍ ଦେଇଛି ଅଲରେଡି, ବଟ୍ ତମେ ନିଜେ କରିବା ପାଇଁ ଟ୍ରାଏ କର। ନିଜେ କଲେ ହିଁ ଜାଣିପାରିବ ତମେ କୋଉଠି ତମର ପ୍ରୋବ୍ଲେମ ରହୁଛି।
ସାର୍ ୟା ପୂର୍ବରୁ ଏବେ ଜଷ୍ଟ ଯୋଉ କ୍ୱେଶ୍ଚନଟା ଡିସ୍କସ୍ କରୁଥିଲେ ସାର୍, ସେଇ କ୍ୱେଶ୍ଚନଟା ଟିକେ ଆଉଥରେ ଯିବେ, ମୋତେ ଟିକେ ଡାଉଟ୍ ଥିଲା।
ଟିକେ ରହ, ମୁଁ ଅପଲୋଡ କରିଦିଏ।
ୟେସ୍ ସାର୍।
ହଉ ଟାଇମ୍ ଲାଗିବ ଏଇଟା। ହଉ ହେଇଗଲା। ପୁରା ଏଇଠି ତ?
ୟେସ୍ ସାର୍।
କୁହ।
ସାର୍ ସେ ଆଙ୍ଗେଲ ଅଫ ଡିପାର୍ଚର ବାହାର କରି ସାରିଲା ପରେ ସାର୍ ତାର ସାର୍ ସେ ଯୋଉ କମ୍ପ୍ଲେକ୍ସ ପୋଲର ତାର ରୁଟ୍ ଲୋକସଟା ମାନେ ସାର୍ ତାର ରିଏଲର କ'ଣ ମିଶିକି ଗୋଟେରେ ହେଇଗଲା?
ହଁ এইଠୁ ବ୍ରେକ୍ କଲା ନା, ଯୋଉ ରିଏଲ ପୋଲରୁ ଯୋଉଟା ଆସିଥିଲା ସେ ବ୍ରେକ୍ କଲା, ଏଇ -2ରେ ବ୍ରେକ୍ କଲା। ତ ବ୍ରେକ୍ କରି କୁଆଡେ ଉପରକୁ ଯିବ, କିନ୍ତୁ ଏପଟେ ଯାଇପାରିବନି ନା, ସେ ବ୍ରେକ୍ କରିକି ଉପରକୁ ହିଁ ଯିବ। ତାହେଲେ ଉପରକୁ ଯାଉଛି ସେତେବେଳେ ଏଇଟା ଯୋଉ -9 ଯୋଉ ସିଧା ତଳକୁ ଆସୁଛି ନା ଏଇ ଯୋଉ କମ୍ପ୍ଲେକ୍ସ ପୋଲରୁ, ତ ସେଟା ସେ ମାନେ ମିଟ୍ କରିପାରନ୍ତି କି କରି ନ ବି ପାରନ୍ତି ହେଲା। ତ ସେଇଟା ପାଇଁ ଆମକୁ ଏଇ ଯୋଉ ପଏଣ୍ଟଟା ପାଇଛୁ ଆମେ, ତାକୁ ଆମେ ଚେକ୍ କରିବା ଯେ ଏଇଟା ଆମର ବ୍ରେକଓଏ ପଏଣ୍ଟ ହବ କି ନାହିଁ। ତ ଏଙ୍ଗଲ କଣ୍ଡିସନ ୟୁଜ କରିକି ଆମେ ଚେକ୍ କରିବା ଯେ ଏଇ କମ୍ପ୍ଲେକ୍ସ ପଏଣ୍ଟଟା ବ୍ରେକଓଏ ପଏଣ୍ଟ ହବା କି ନାହିଁ। ଯଦି ବ୍ରେକଓଏ ପଏଣ୍ଟ ଯଦି ହଉଥିବ ତାହେଲେ ଦେନ୍ ରୁଟ୍ ଲୋକସ୍ ଗୁଡ଼ା ସେଠି ମିଟ୍ କରିବ।
ସାର୍ ନାଇଁ, ସେ ଗ୍ରାଫଟା କଥା କହୁଛି, ମାନେ ଯୋଉ କର୍ଭଟା ଆପଣ ଟାଣିଛନ୍ତି ନା, ସେଇଟା ମାନେ -2 ଆଉ +2.45 ରେ ପାସ୍ କରୁଛି।
ହଁ ସେଟା ସେଇ ପଏଣ୍ଟ ଅଛି। ଏଇ ପଏଣ୍ଟଟା ହେଲା, এই পয়েন্টটা -2 প্লাস this J 2.45। Similarly এটা -2 minus J 2.45 এই পয়েন্টটা ব্রেকওয়ে পয়েন্টটা।
ସାର୍ ଯଦି ପାସ୍ କରିନଥାନ୍ତା ତାହେଲେ ସାର୍ ତା ପାଇଁ ଆଉ ଗୋଟେ ରୁଟ୍ ଲୋକସ୍ ବାହାରିଥାନ୍ତା, ମାନେ
ସପୋଜ ଯଦି ଏଠି ପାସ୍ କରୁନଥାନ୍ତା ହେଲା, ହଁ ଯଦି ସପୋଜ ପାସ୍ କରିଥାନ୍ତା ଦେନ୍ ତାହେଲେ ଏଇ ରୁଟ୍ ଲୋକସଟା ଏପଟେ ଯାଇଥାନ୍ତା ଆଇଦର, ଆଉ ଏଇ ରୁଟ୍ ଲୋକସଟା ଏପଟେ ଫଲୋ କରିଥାନ୍ତା। ଏ ଯୋଉ ରିଏଲ ପୋଲ ଯୋଉଟା ଆସିଲା ସେ ଯାଇଥାନ୍ତା ଏପଟେ, ଆଉ ଏ କମ୍ପ୍ଲେକ୍ସ ପୋଲରୁ ସେ ଏଇ ଏସ୍ ନୋଟକୁ ଫଲୋ କରିଥାନ୍ତା। ସେଇଟା ଏଇ ଏକ୍ଜାମ୍ପଲଟା ଅଛି ହେଲା, ଏଇ ଏକ୍ଜାମ୍ପଲଟା ଦେଖିବ। ଏଇଟା A by S into S plus 6 S square plus 4S plus 13। এটা ବି କମ୍ପ୍ଲେକ୍ସ ଅଛି। ତ ଗୋଟେ ଯାଇଛି ଏଠୁ ଏପଟେ ଯାଇଛି, ଆଉ ଏଇଟା ଏଇପଟେ। ତମେ ଦେଖିବ ଏଇଟା ଏକ୍ଜାମ୍ପଲଟା ବହୁତ ଇଜି ଅଛି, ଏଇଟା ହେଇଯିବ, କିଛି ଅସୁବିଧା ନାହିଁ। ଆଉ କାହାର କିଛି ଡାଉଟ୍ ନାହିଁ? ଆଦ୍ୟା ସାର୍ ଅଛି ନା ନାହିଁ? ଶୁଣୁଛି ନା ଆଦ୍ୟା ସାର୍? ବୁଝି ହେଲା ନା ବୁଝି ହେଲାନି? ରୁଟ୍ ଲୋକସ୍ ହେଲା? କନଫିଡେନ୍ସରେ କହୁନୁ ଆଉ। ହଉ ଛାଡ଼। ଐଶ୍ୱର୍ଯ୍ୟା ମାନେ ସତରେ ବୁଝୁଛ ନା ଖାଲି ହଁ ହଁ କହୁଛ? ଅମିତ ସିଓର ତ? ନହେଲେ ଯାଇକି କହିବ ସାର୍ ବୁଝେଇ ପାରୁନାହାନ୍ତି, ଆମେ କଣ ବୁଝିପାରୁନୁ।